Projectors are usually used to create large-sized screens that normal LCD TVs can't produce. They're an output device. They use computer outputs to create a large image. They're mostly used for interactive whiteboards, presentations, and obviously cinemas, etc. There are two types of light projection. One type is DLP. The DLP projector system requires 7 components to function: a light source, a condensing filter, a color filter, a shaping lens, a DMD chip, a memory, a DLP chip, and a projection lens. To understand how the system works, you'll first need to understand what the main processes are, because those are quite complicated. So first, we have the DLP chip, which decodes a bit-streamed image code. Next, we have the DMD chip, which has millions of micromirrors on it. Underneath those mirrors are tiny hinges, which allow the mirrors to tilt up to 12 degrees. The mirrors tilt towards the light source. That means they're on, and when they tilt away, they're off. This creates a light or dark pixel on the screen. The mirrors can switch several thousand times per second, creating various shades of gray. Typically, 1024 shades of gray can be produced. For example, if the micromirrors switch on more than off, they'll produce a lighter shade of gray. This is known as the grayscale image. Each mirror is in charge of creating 1 pixel on the projected image. The DLP chip, which has decoded the bit-streamed image code, will tell the mirrors which way to tilt to create the image. To get color, the light travels through a transparent color filter onto the DMD chip. The color wheel is synchronized with the DLP chip to project the colors onto the mirror. The color filter is comprised of only 3 colors: red, green, and blue. The DLP system relies on the viewer to blend the pixels into the desired color. For example, a mirror responsible for creating a purple pixel will only reflect blue and red light. The pixel itself will be rapidly alternating blue and red. Our eyes will blend these lights together to see purple. A single chip DLP system will be able to create 16.7 million colors. So the process of creating an image is this. First, a stream of light will come from the light source, which will go through a condensing lens, which basically turns the stream of light into a more condensed stream of light. What you can tell from the word condensing. Yeah. That condensed stream of light goes through a color filter, which is projected onto the millions of mirrors, which passes through a projection lens onto the big screen. The other common type of projection is LCD projection, which is much older technology than DLP projection. First, a strong, intense white beam of light is emitted. Our beam of light bounces off 2 dichroic mirrors, which are coated in a special film to reflect specific wavelengths of light. This works because colors are only visible at specific wavelengths. Longer wavelengths let you see red, and shorter wavelengths let you see the color blue. Our beam of light bounces off the first dichroic mirror to produce the color red. The remaining light bounces off another dichroic mirror, producing the color green. The last color must be blue, so a normal mirror is placed instead of a special coated one. This system is designed to separate the 3 colors like a prism. The 3 colors of light continue its journey through a liquid crystal display, LCD. The liquid crystal display is comprised of thousands of tiny pixels, which will either block or allow light to pass through when triggered by an electric current. When the light passes through the LCD, it relays 3 of the same grayscale image. Grayscale basically means monochrome, just 1 color, of different shades. But of course, the final image we see isn't just red, blue, or green, it's full color. So in the LCD projector, the 3 images can recombine in a dichroic prism to form an image of not just 3 colors, but of millions of colors. The last step is for the image to pass through the projector lens and onto the big screen. I hope it's now clear how the 2 most common projectors work. Thanks for watching.